Here it's problem 10-144, finding birthday twins. If you randomly select a group of just 21 people, the chance of there being a pair of people with the same birthday is greater than 50%. This surprising fact is due to the large number of pairings possible in a group of 21 people. So I don't know if you remember, we've been studying combinations and permutations. We're going to use combinations. So here's our formula for combinations. This is a combination of n things taken r at a time. So letter A says determine the number of possible unique pairings of a group of 21 people. So that's going to be 21 people taken 2 at a time because pairing means 2. So 21 factorial over, that's n minus r, and that's r factorial. So I just did it all, showed all my work. I like to, this is 21, this would go 21 times 20 times 19 times 18 times 17, but I chose not to write the 19, 18, and 17 because I canceled it out with this 19. And then the 2 canceled out with the 20, and I get 210. So what that does for us is it's kind of like, I don't know if you remember this problem. There's a problem back here, this problem. It was a tree diagram. And you can draw the big giant tree diagram for this, but let's not, because that would take a lot of work. What this combination gives you is how many of these outcomes would be a birthday pairing. So there's 210 of these. Okay, so when it asks me on letter B, it says compute the probability that any given pair of people have the same birthday, ignoring leap day. Well, letter B would just be like, say, my birthday is October 5th. So the chance that someone else, like just any person, has the same birthday as me, like the chance that I walk up to some other person and say, hey, is your birthday also October 5th? That would just be, the person could say there's 365 days, and they could say any one of those 365 days. So that's what that means right there. That's just the probability that you would just find another person that has the same birthday as you. Okay, but letter C says compute the probability that any given pair of people do not have the same birthday. Well, on that one, you would just want to, you can just subtract from 1. So if the probability that you do have the same birthday as me is 1 out of 365, then the probability that you don't have the same birthday as mine is 364 out of 365. Letter D says, now compute the probability that exactly one pair of the 21 people has the same birthdays. So this, it's kind of, I mean, you can read the answer. It's kind of hard to understand where they got all the numbers from, though. So that's what I'm guessing the question is about. So if you remember back here, when you do make a tree diagram, you know how you have to multiply this times this times this times this? Well, that's what these numbers are. There's 210, and the 210 is like, it would be an enormous tree diagram that I couldn't even show you, but there'd be 210 pairings, birthday pairings out of if there's a group of 21 people. We did that by finding the combination of 21 people taken 2 at a time. And then you would multiply that by all these little numbers, that led to those pairings. So all the little numbers would be, there's 1 out of 365 times 20, like this would be to the first power. Like one of them, see how there's like this one's a 40, but that one's a 60. It's like one of these pairings would be 1 out of 365, and then the rest, the other 20, would be 364 out of 365. So you multiply those all together, and that's where you get the 54.46%. So that's why they're telling you right here that the probability of there being a pair of people with the same birthday is greater than 50%.